Then another configuration is a voltage divider bias. So this is our voltage divider bias. Then you have to convert that or get the easy model of your amplifier and plotting all the current that will flow to your amplifier. We have IS, IB, then we have IO, IO prime, I and IC, then we have IE. This is your voltage at the base, where we can get your impedance at the base, voltage input, that is impedance I and impedance IN. For your output, so this is our output impedance. So solving for your input impedance, first we have to get the impedance at the base through your voltage at the base. So we have I equals to BO minus B over RO. Then RO is equals to negative RL times IO. And we have IO equals to opposite resistance over opposite resistance plus RL times IO prime. So therefore, BO is equals to negative RL in parallel with RC times IO prime. And BE is RE times IE. If you have to get the equation of your IO prime at the collector or at C, so we have IO prime equals to beta IB plus I beta IB, that is your IC. Then substituting the value of your BO and BE for your I, then you have to group all same variable. So we have IO prime on your left side and IB with IE on your right side. So this is now our equation of your IO prime. It is beta RO IB minus RE IE all over RO plus RL in parallel with RC. And IE is equals to IB plus IO prime. So we have IB plus your IO prime. Then you have to combine all your variables. So we have IE on your left side and IB on the right side. Get the LCD of both sides and get the ratio of your IE in terms of IB. So since voltage base is beta RAIB plus RAIE, then we have to substitute your IE to your IE in your voltage at the base. So if we have to divide this voltage at the base with the current IB, so that is equivalent to your impedance base or impedance base. So impedance at the base is beta RA plus RE times the quantity RO plus RL parallel with RC plus beta RO all over RO plus RL in parallel with RC plus RE. So for your impedance I, that is RB in parallel with impedance the base, and impedance IN, that is equivalent to RS plus your impedance I. So this is only I. Output impedance when BS is set to 0. So we have this value of your output impedance. Voltage gain, so we have already our BO and our BI, which is equivalent to our voltage base. So if we have to get the ratio of BO over BI, so we have now this equation of your voltage gain, BO over BI. But our voltage gain is BO over BS. So we have to get your equation of BI over BS. That is impedance I over impedance IN. So voltage at the base EBS is equals to voltage gain times impedance I over impedance IN. And for the current gain, it is IO over IS. So we have to use your ABS equation to solve for your EIS. So we have your BO since we are looking for the equation of your I/O can be found at your VO, which is negative RL times I/O. So we have negative VO over RL for your I/O. And for the IS, it is within your BS. So IS is BS over impedance IN. Substituting that one to your EIS, so therefore EIS equals to negative ABS times input impedance over RL. So we have this example. So first, we have to get your RE so that we can solve for your beta RE. So using DC analysis, since this is a voltage divider bias, so you have to use Thevenin's theorem. So we have to remove the load and replace with voltmeter. Then therefore we have your VTH equivalent to 4.8 volts. And we have to remove the voltmeter and replace with ohmmeter. Then we have RTH equals to 96 kilo ohms. And we have to redraw the circuits. So this is now our Thevenin circuits. So getting the equation of the loop from 4.8 going to 750. And solving for your IE. So we have to express your equation in terms of IB. In terms of IE, not IB. So this is the equation of your IE. It is 4.8 minus 0.7 over 96k over 100 plus 750. Why 100? Because your beta is 99. So therefore, IE is equals to this value. Solving for your RE, that is 26 millivolts over IE. So this is your RE and beta RE. So this is our current IS, IB, IO, IC, then IE. Voltage at the base, voltage I, and output impedance. So we have to solve for your input impedance. So that is beta RE IB plus 750 IE. We have to express IE in terms of IB. So we have voltage at the base as beta RE IB plus 750 times 100 times IB. If we have to divide this by IB, then we have your resistance. So we have your impedance base is 76.07354634 kilo ohms. Then to solve for your impedance I, so we have to get the parallel of your impedance base with 96k. So that is 42.441506 kilo ohms. And impedance IN, just add your RS, which is 1k. So this is our impedance IN. For output impedance, setting BS to 0, so we have 2k in parallel with 2k. So this is your output impedance. Then for the voltage gain, which is B over BS, we have already our BI. And for BO, so we have this BO. So we have to get the ratio B over BI. So we have now negative 1.363342327. That is B over BI. But your voltage gain, that is B over BS. So we have to get the equation of your BI in terms of BS, or the ratio BI over BS. So that is equals to input impedance I over impedance IN. Your ABS, which is equals to B over BS, equals to negative 133,195,8,923. For the current gain, just use the ABS formula. So we have negative ABS times impedance IN over 2K. So we have 28.93115078 as our current gain. Then output voltage, we have BO over BS. So if if you have to solve for BO, so BO is equals to ABS times BS. So BO is equals to negative 13.31958.923 millivolts. So that's all for the voltage divider bias RE model.